We got these parts in because they were curious about run out and possible discrepancies for sizes, but I just kind of wanted to show the pumps too because these are cool pumps. Now, run out on this is a little bit tough. I just turned this shaft down so it's running true, and I can see I've got about 3/1000 run out, which it's supposed to have 2/1000 between this and the taper. But then there's going to be some run out in the taper itself. So 3/1000 total is fully reasonable. And we'll go back and check the measurement too in a minute. But what's so neat about this design of pump is when you build them up from the bottom, and there's a different piece that goes on the bottom, and then you have a shaft that goes through here. And you just drop in one of your impellers on your shaft, and then there's if we had the shaft here, and then there's this tapered collar. The tapered collar, you slide it on, and then you have just like a post driver for fence post. You slam that down, then you'd bolt your next section onto here, and you'd do the same thing again. More sections you line up, the higher pressure the pump is for. And you line these up for vertical line shafts. And what's so neat about that is on a lot of things like this, you'd have to have the real close spacing between the different pumps. But by having this tapered lock that you drive in, you just let gravity hold them all to one side. And then when you're done, you bring them up nominally 3/16 of an inch is what the ones I used to work with, which were about this size. Plus, they had a formula for length of stretch depending on how much shaft you had, because these might be on 200 or 300 foot of shaft down in a well with the motor setting up on top. They're pretty cool pumps anyway. And I used to rebuild a bunch of them just about this size years ago, and I always thought they were just a neat mechanical thing.